Previously, we learned how to use the mean and the standard deviation of a dataset to figure out the shape of the distribution and the outliers. Next, we will learn how to do the same using the other numerical summaries. The following values together are called the 5-number summary of a dataset. Alternatively, we can think of the list as the 0th, 25th, 50th, 75th, and 100th percentiles. Before finding the 5-number summary by hand, we have to make sure that the data is organized in ascending order. Then it will be easier to find the minimum and the maximum. We already know how to find the median that divides the dataset into two halves, top and bottom. For simplicity, we're going to define the Q1 as the median of the bottom half and Q3 as the median of the top half. Consider the following example: the ages of the US presidents at their inaugurations. For convenience, it is already organized in ascending order. So let's determine the 5-number summary. The minimum is 42 and the maximum is 70. The number of observations is 45, which is an odd number, so the median is 55, the 23rd observation that divides the data into upper 22 observations and lower 22 observations. In the bottom half, the number of observations is 22, which is an even number, so the median of the bottom half is the average between the 11th and 12th observations, which is 51. Similarly, in the upper half, the number of observations is 22, which is an even number, so the median of the upper half is an average between the 11th and the 12th observations, which is 59. Thus, the 5-number summary is provided in the following table. One of the two goals that we are trying to accomplish is to learn how to identify the outliers. For that, we are going to need the following vocabulary. The interquartile range IQR is the difference between the Q3 and Q1, or in other words, it is the width of the middle 50%. The values Q1 minus 1.5 IQR and Q3 plus 1.5 IQR are called the lower limit and the upper limit of a dataset. Values that are greater than the upper limit or less than the lower limit are called outliers. The other goal that we are trying to accomplish is to learn how to visualize a dataset. For that, we're going to need the following vocabulary. A boxplot, also called a box and whisker diagram, is based on the 5-number summary and can be used to provide a graphical display of the center and variation of a dataset. To construct a boxplot, we also need the concept of adjacent values. The adjacent values of a dataset are the most extreme observations that still lie within the lower and upper limits. They are the most extreme observations that are not outliers. Note that if a dataset has no potential outliers, the adjacent values are just the minimum and maximum observations. To construct a boxplot, we're going to determine the quartiles and construct the 5-number summary first. Then we'll use the formulas to determine the outliers and adjacent values, if any. Then we'll draw a horizontal axis on which the numbers obtained in steps 1 and 2 can be located. Above this axis, we'll mark the quartiles and the adjacent values with vertical lines. We'll connect the quartiles to make a box, and then connect the box to the adjacent values with lines. If there are outliers, we'll mark them with an asterisk. Note that one can skip steps 2 and 5 if not concerned about outliers at all. In such a case, the adjacent values are the minimum and the maximum values in the 5-number summary. Let's construct the boxplot for the president's ages at inauguration, for which we already found the 5-number summary. First, let's compute IQR by subtracting Q1 from Q3. It is equal to 8. Then let's find what's times and a half IQR. 1.5 times 8 is 12. Next, let's compute the lower limit by subtracting 1.5 IQR from Q1. We get 39. Now let's compute the upper limit by adding times.5 IQR to Q3. We got 71. Since all the values are within the lower and upper limits, there are no outliers and therefore there is no need to compute adjacent values. Next, we're going to draw the box plot by creating the horizontal axis first and then drawing the vertical lines for each value in the 5-number summary and connecting them with horizontal lines to form the box plot. After the box plot is constructed, we can check the following chart to identify the shape of the distribution. It appears that the shape of the distribution of the president's ages is normal. We discuss how to use the 5-number summary to identify the outliers and to visualize the data by constructing a box plot.